Hello, welcome to 11.8 Power Series. So in this section, we're going to learn what is power series and then discuss for what x value the power series is going to be converges. Okay, so firstly, let's take a look at the definition. A power series about x equals 0 is a series of the form sum of Cnxn, and if we rewrite this out, is equals C0 plus C1x plus C2x squared plus Cnxn. So this is like a polynomial, but this is just infinite. We have infinite terms here. And this is also a combination of all the power functions. So you can see all the power functions. That's why it's called power series. Okay. More general, a power series about x equals a is the series of this form. So you just change x into x minus a in the series. So it's going to be this form, change x into x minus a, x minus a, x minus a. All the terms has x minus a. So the series about 0 actually is a special case of x at a, when a is 0, right? And a is called the center. And all the Cn, they are called coefficients. Okay, coefficients. So about 0, the center is 0. The first one is has center 0, and the more general, center A. Now let's take a look at the first example. For what value of x do the series converge? And this is our first series, first problem. This is alternating series, and this has center 0, right? Because just x to the power n. And let's see, we are going to test the series for absolutely converges or not. Okay, so we're going to test this thing. And here we like to use the ratio test. You can also use the root test, also works for this problem. So I'm going to use the ratio test to f value of an or plus 1 over an to the f value. So when we take the f value of the an, the sign will just go away because this is positive, negative. When we take the f value, it's always be positive, right? So it goes into be x to the n plus 1 over n plus 1 times n x to the n. Okay, divide by an. So here just write down times the reciprocal directly. Now simplify. Cancelled x to the n and x left here. And we still need to put the f value here because we don't know x is positive or negative. Okay, like this. And let's take a look at the limit. So limit of n over n plus 1 goes to 1. So the whole thing, the limit goes to x value. Let's take a look at have a review of ratio test. Ratio test means when the limit of an plus 1 over an goes to rho, and the rho is less than 1, converge. Rho is greater than 1, diverge, and the rho equals 1, inconclusive. Right. So in our case, we are looking for what? For what value of x do the series converge? So we are looking for the x value to make this converge. So how to make this converge when the rho less than 1? That means when x value is less than 1, our series O x greater than, if I write down the interval like this, write the inequality in another way, and the series an converge absolutely. Converge absolutely, right? And then converge. Okay. So this and you know, when x value greater than 1, the series diverge. But let's see, when x value equals 1, in the ratio test is inconclusive. That means the ratio test cannot tell it's converge or diverge when the rho equals 1. That means for this case, x f value equals 1. We don't know it's converge or diverge. So we are going to plug in. When x value equals 1, is maybe x equals 1 or x equals -1. And we plug into our series. Okay. Our series is just copy our original series, but we change x into 1. So 1 to the power n actually is just 1, right? So we don't have to write down the n here, just 1 over n. Do you know what do we call this series? This is called alternating series. And in alternating series section, we use the alternating test. Proof this is converges series, right? And when x equals -1, let's take a look. Same thing, we plug into our original series. So here is -1 to the power n, change x into -1. Simplify this series. -1 to the combine those two together becomes what? 2n-1 over n. That's right, simplify. And we notice that 2n-1 is an odd number. Okay, so 91 to the odd number equals what? Just -1. 91 to the even number equals +1, right? So simplify. Now we take the, so it's like 91 over n. And then we can take the -1 to the front. And this is just harmonic series, and we know that's diverge. Okay, so now let's take a look at this problem. For what value this series converge? When x is greater than -1 and less than 1, it's converge, right? And then what else? When x equals 1, that converge. So we just combine everything together. So for x greater than -1, less and equal to 1, our series converge. Now let's take a look at the second problem. Okay, we will do several problems here, then you'll have some good idea how does this work. The second series look like this. N start from 0, x to the power n, n factorial, and if we write this out, power series, right? Okay, now let's see. We do the same thing as the first problem. We do the ratio test to the absolute value of an. This equals to x to the n plus 1 over n plus 1 factorial times n factorial x to the power n. Simplify. N factorial cancel with that n plus 1. And this equals, and the x to the n cancel with that x left. Clean up. X on the top over n plus 1, right? So let's take a look at this limit. This limit goes to what? N goes to infinity, denominator goes to infinity, so whole thing goes to 0. Is that right? So this means what? So this means the series converge absolutely for all x, for every x and less than 1, right? This is 0. So the series converge absolutely for all x. Okay. Number 3. Take a look. N equals 0 to infinity, n factorial x to the n. Same thing. Ratio test. N plus 1 factorial x to the n plus 1 over an n factorial x to the n. Simplify. N plus 1 left, x left. So this equals what? N plus 1 times x. So this will goes to infinity. When the row goes to infinity, we know diverges, right? So this goes to infinity unless x equals 0, except 0. Otherwise, it diverges for all x except x equals 0. So we can try the exercise problem. So here we did 3 problems, right? So exercise is similar. Plus 2. Okay. I'm going to give you the solution for this one. We always do the same thing. Here, n plus 1 plus 2 because n plus 3. An n plus 2. Simplify. Cancel this. So it becomes n plus 1, n plus 2, x over n times n plus 3. So you can see everything here goes to limit 1 after simplify, because the coefficient in front of n squared, they both have 1. So this limit goes to xf value, and then we need this to be less than 1 for convergence. So we say when this, for this value, the series converges absolutely, then converges, right? But we didn't tell when x value equals 1 is converge or diverge. So we need to say for x value equals 1, same thing we do, x equals 1, x equals -1. Plug in. Our series becomes n over n plus 2. The other one, if we plug in -1, becomes -1 to the n over n plus 2. Okay, so let's take a look at the first one. The first one, by looking at an, we know the an goes to limit 1, right? Yes. So, okay, we know n over goes to 1, different from 0, so we use the nth term divergence test. This series diverges. Okay, by using that. When x equals -1, we can take a look. This is our series, and we notice that this is alternating series, right? So we are going to use alternating test. Alternating test has three parts. So it's un positive, decreasing goes to 0. But look at this one. Our un equals what? N over n plus 2. Does this go to 0? No, it goes to 1 actually. So it doesn't satisfy the alternating test. So this series also diverges. Now we combine everything together. For what x value the series converge. So when x greater than -1 and less than 1 only, so when equals -1 and the +1, -1, they both diverge. So only for this x value, our series converges. Okay, that's the exercise problem. Now let's take a look at example 2. This is general power series, has center at 3, is not center at 0. Let's take a look. For what value? Same thing. Does this series converge? Okay. We do the same thing. Like the ratio, like example 1, we do all the ratio test to absolute values of an. So let's write down this. It's going to be x minus 3 to the n plus 1 power, right? And over n plus 1. So this is an plus 1. And then times n x minus 3 to the n. Simplify. Cancel that with that. X minus 3 left. So it's going to be x minus 3 n over n plus 1. Is that correct? And then find the limit of this thing. Limit is just x minus 3. And this is the limit row. So we know when this less than 1, our series converges. So we need x minus 3. The series converges. Absolutely, actually, and also converges, right? And can we also solve this? Do you know how to solve this inequality? That means same as that, right? And then we move 3 to both sides. This is called the compound inequality. So on the right side, x less than 4. On the left side, 91 plus 3 should be 2. Is that right? So for x greater than 2 and 4 is converges. Okay, we box this answer. And next, we need to know when x minus 3 equals 1. Okay, so that just means the endpoint. You can just take a look at those two numbers. Okay. Next, we say, so first step, second, when x equals to 2. When x equals to 2, x minus 3 absolute value equals 1. So when x equals 2, we plug into our original series. So 2 minus 3 to the n over n. Simplify. It then becomes 91 to the n over n. Harmonic, alternating harmonic, and this we know converge. Right? Third, at the other endpoint, x equals 4. Okay. So they all means when the row equals 1. When x minus 3 absolute value equals 1. Okay, that's why because equals 1, there's no conclusive, so we have to test them separately. Plug into our original series 4 minus 3 to the n over n. 1 over n. 1 to the power n is also 1, right? And we know this is harmonic divergence. Now, combine this and this. Write down them together. So, when x greater equal to 2, right? And cannot equal to 4, less than 4, the series converges. Okay. This is example 2. Let's try the exercise. Okay, so here's the solution to the exercise problem. Now let's take a look at our example 1. Example 1, we did 3 problems, right? So the first case, you can see this is our x value, and let's make the series converges. And the second one, the series converges for all x. And the third one, except 0. So diverges for all x except 0. So only for x equals 0 is converges. And also for power series, I'm going to give you the theorem next. There are only 3 possibilities for all x, for only one point of x, or for interval of x, the series converges. Now let's take a look at the theorem. For given series, and this series is power series, is Cn x minus a to the power n, centered at a. There are only 3 possibilities. Okay, and the first one, the series converges only when x equals a. The second one, the series converges for all x. Next, there is a positive number r such that the series converges in the interval converges if x minus a absolute value is less than r, and diverges if x minus a absolute value is greater than r, and the series may or may not converge at the endpoint. May or may not converges at the endpoints. So what's the endpoints are? They are x equals a minus r and the x equals a plus r endpoints. So it's kind of like we have an interval. For example, x minus 1 less than 2. What's the meaning? So here's 1. X minus 1 absolute value less than 2. So this is 2. So here's 3. And here's 0. So it should be 91. So from 91 to 3, what is our r? R is 2. Okay? And a is 1. And our endpoints are 91 and 3. And we don't know may or may not converges, diverges. Same as our previous examples. Okay, so now we have definition. We define the capital R as the radius of convergence. So, definition 2. The number R, okay, is called the radius. Why is called radius? You can look at my graph. Radius of convergence. Okay. And the interval of radius R centered at A is called interval of convergence. I'm going to show the example after the definition, and it may be closed or open. Open or half open. Okay, so what's the meaning? If we look at the previous example, we get something like x, for example, x minus 2 need to be less than 1. So what is our radius? That is 1, right? And what is, so for the example 2, let's take a look at, let's take a look at the exercise problem. X, that is also x plus 2 less than 1, and the final answer is this one, right? -3 and that's equal to -1. So maybe closed or open at the points. That's the meaning of this. And this is called interval of convergence. Okay, and R is the radius of convergence. Okay, so that's all we need to know. So in the homework, you may see find the interval of convergence. You just do the same thing like 3 parts. Ratio test to absolute value of an, and then endpoint 1 and point 2, and discuss converges or diverges, and then combine all them together, you get interval. Okay, and we can stop this section now.